So today we are going to discuss acidity of COOH group, means acidity of carboxylic acid group. Now these are the few reactions that shows acidic property of COOH. You can see when COOH reacts with sodium metal, it liberates hydrogen gas and makes a sodium carboxylate salt. Sodium carboxylate salt. Whereas when carboxylic acid reacts with NaOH, sodium hydroxide, it makes same sodium carboxylate ion plus water, because you know NaOH is base and COOH, that is acid. Acid plus base makes salt and water. Similarly, this one is also base, but mild base. NaHCO3, sodium bicarbonate, when it reacts with COOH, it gives sodium carboxylate plus carbon dioxide plus water molecule. These three reactions shows acidic nature of COOH group. Now, presence of electron withdrawing group. What if electron withdrawing group is present in the structure? So look at this structure. Here we have carboxylate ion, means H plus is missing from COOH group. Now acid has tendency to donate H plus. That's why I have written here COO minus ion. Okay, because acid has tendency to donate H plus. Now electron withdrawing group is there. So what it does, when this negative ion is there, it withdraws some negative part from COO minus ion. So this minus ion becomes little bit stable. So due to that stability, acidic property of this structure increases. Okay. So here I have written, as shown in figure, when electron withdrawing group is there in structure, it attracts negative charge from the COO minus ion. So negative ion becomes more stable. In this way, electron withdrawing group makes acid more strong, increases acidic property. Okay. So presence of electron withdrawing group makes acid more strong. Opposite to that, what if electron donating group is present in the structure? You can see this structure, same ion I have written here, COO minus ion, carboxylate ion. When electron donating group is there in the structure, what it does, it donates electron to the negative part, so repulsion will be there. So negative ion becomes less stable due to repulsion. So here I have written that, as shown in figure, if electron donating group is there in the structure, it donates electron to the negative ion. So negative ion becomes unstable, making acid weak. In this way, presence of electron donating group makes acid weak. Okay. Presence of electron withdrawing group makes acid stronger, and presence of electron donating group makes acid weak. Now here is the order of increasing acidity order. You can see CF3, that is the most electron withdrawing group. So it increases the acidity. Then NO2, then cyanide group, then fluorine, Cl, Br, I, and phenyl group. pH means phenyl group. So this is the electron withdrawing property. In this way, electron withdrawing property increases. So this makes most strong acid, and among this phenyl group makes least strong acid. Okay. Now here's the order of acids according to their acidity. So you can see CF3COOH that we have discussed here. it is most strong acid, then Cl3COOH, then CHCl2COOH. In this way the order is here. You can write the order. Order is important for MCQ purpose. Now, what is the acidic property in aromatic structure? So here also presence of electron withdrawing group makes acid stronger. You can see these three structures. NO2 is electron withdrawing group. OCH3 means ether group, that is electron donating group, and this one has no group on it other than COOH. So presence of electron withdrawing group makes acid stronger. So it is most acidic property. It has most acidic property than COOH only. Then this makes acid weak. Electron donating group makes acid weak. So this is the least acidic structure. Now one thing is very important here. As acidity increases, pH decreases, and pKa value that also decreases here. So if they ask question according to pH or pKa, so what you have to find? You have to remember this relation. Acidity increases, pH decreases, and pKa also decreases. Next one, reaction of carboxylic acid group, COOH group. So here are some reactions of COOH group. First reaction, that is formation of anhydride. Now you can see I have taken two same molecule, acetic acid. This written inverted only. So two acetic acid molecule when combines and we heat it in presence of acidic, means we heat it, or catalyst is P2O5 here. So what will happen here? You can see OH and H, they form H2O. So H2O will lose here, making this structure CH3COO. You can see this part, then O, C double bond O, CH3. So this is the anhydride. Okay, acetic anhydride it is. So in this way you can make anhydride. When two molecules of acid, carboxylic acid, combines and loses water molecule, then anhydride forms. Next one is esterification. Now esterification reaction you must have learned. Acid plus alcohol. In presence of acidic medium, it gives ester plus water molecule, and it is backward and forward, both type of reaction that can give. Now here is the example. You can see it is acetic acid and methanol. When reacts in presence of acid, it gives what you have to do? H and OH. Combine them. So H2O will be there. CH3COO that remains here. CH3COO. Remaining part of second molecule is CH3. So attach that. CH3. So it makes ester here. Next reaction is reaction with PCl3, PCl5 and SOCl2, thionyl chloride. Now we have learned PCl3, PCl5 and SOCl2 in 10th chapter. Reaction with alcohol. Same type of reaction comes here. You can see RCOOH, that is carboxylic acid, when reacts with PCl5, phosphorus pentachloride, what it does, remove this OH and instead of that attach Cl. Remove this OH, instead of that attach Cl. It is substitution reaction. As byproduct we will get POCl3 and HCl. Now in case of PCl3, the main product remains same. Instead of OH, write down Cl. Byproduct changes here, H3PO3. That is the byproduct in case of PCl3. Now the last one is SOCl2, reaction with SOCl2. Same way you have to replace this OH with Cl. You can see, instead of OH, write down Cl. Byproduct will be sulfur dioxide and HCl. That byproduct are same as in alcohol. Next one is reaction with ammonia, NH3. So you can see, ammonia is base here. This one is acid. So it will make water and salt. So as salt, we'll get here amide, CONH2, OH from here and H from amine. That will lose here as H2O and form CONH2, amide group. Here a specific example is there. You can see this one, dicarboxylic acid is there. Name of this compound is 1,2-dicarboxylic acid benzene 1,2-dicarboxylic acid. When it reacts with ammonia, what happens here? We have two COOH group, so attach, it makes two CONH2 group, two amide group, because we have two COOH groups. So you can see here, two amide groups are there. Now if we heat it, what happens here? This NH2 and hydrogen from here, that leaves in form of ammonia gas, making a cyclic structure, and that is called phthalimide. This P is silent here, it is called phthalimide. Okay, so it is preparation of phthalimide from benzene 1,2-dicarboxylic acid. Next reaction is reduction reaction of COOH group. Now to reduce COOH group, we require strong reducing agent, and we have learned in previous chapter also that strong reducing agent is palladium in hydrogen and lithium aluminium hydride. So here I am using lithium aluminium hydride. You can see CH3COOH in presence of lithium aluminium hydride, and when we use lithium aluminium hydride, in second step you have to use H2O. That I told you in previous chapter also. Whenever you use lithium aluminium hydride, in second step you have to use water. So it makes alcohol. Number of carbon remains same. You can see 2 carbons are here, 2 carbons are here. So number of carbon remains same. Just instead of carboxylic acid group, you have to write alcohol group. Next reaction is decarboxylation reaction. So by the name only, it tells us that from COOH group, this carboxyl group, COO group, that loses here, making CH plus carbon dioxide. This carbon dioxide combines with other molecule to form Na2CO3. You can see the reaction RCOO. This reaction is performed in presence of soda lime. What is soda lime? Soda lime is NaOH plus CaO. And heat it, so you will get simple alkane and Na2CO3 as byproduct. Now here one thing is important. You can see a carbon is losing from is less here. So it is step down reaction. One carbon is less than the starting material. So it is step down reaction. The last reaction is Hell-Volhard-Zelinsky reaction. It is named reaction. What it does, here you can see this is our COOH group. Adjacent to that is our alpha carbon. Now from alpha carbon you have to replace hydrogen with chlorine. Again, from alpha carbon you have to replace hydrogen with chlorine here. So for that we are using Cl2 and red phosphorus. Red phosphorus is catalyst here. And in second step, water molecule you have to react here. So you will get alpha chloro acid. Here instead of Cl you can take Br also. As halogen you can take chlorine and bromine. Okay, so that's it for today. Thank you.